problem 3, we first need to calculate the probability that data 0 is received. Here we first give the notation Ri to denote signal I is being received. And we also denote Si as signal data I is sent. And for the first part, we need to calculate the probability of R0. We can expand this probability based on the formula here, and it is equal to the sum of the probability that signal 0 is received given that signal I is sent times the probability that signal I is sent. And I here is ranging from 0 to 1. And we can rewrite it as plus the probability that signal 0 is received given that signal 1 is sent times the probability that signal 1 is sent. And based on what is known in the problem, we know that this one, the probability that signal 0 is sent while signal 0 is received, equals to 0.7, and the probability that the signal 0 is sent is 0.6. And this one, the probability that signal 1 is sent, the probability that signal 0 is received given that signal 1 is sent, equals to 0.2, and the probability that signal 1 is sent equals to 0.4. And by adding these two, we got 0.5. And this is the first part of the problem 3. And for the second part, we need to calculate the probability of error. It's combination of two probabilities. The first one is that signal 1 is received when signal 0 is sent. So we can write P error equals to P signal 1 is received while signal 0 is sent, plus the probability that signal 0 is received given that signal 1 is sent. And we can rewrite this probability by the formula here, which is the conditional probability formula, and it can be rewritten as the probability that signal 0 is received given that signal 1 is sent times the probability that signal 1 is sent plus the probability that signal 1 is received given that signal 0 is sent times the probability that signal 0 is sent. Times the probability that signal 0 is sent. And based on what's stated in the problem, we know that this one equals to 0.2, and the probability that signal 1 is sent equals to 0.4, and the probability that signal 1 is received given that signal 0 is sent equals to 0.6, while the probability that signal 0 the probability that signal 1 is received given that signal 0 is sent equals to 0.3, and the probability that signal 0 is sent equals to 0.6. So by adding these two, we got 0.26, and this is for the part 2 of problem 3.